Hi, my name's Jim Minter and I'm a solution architect working with Red Hat's financial services customers in the UK. This webcast shows an integration between our OpenShift Platform as a Service product and OpenStack Infrastructure as a Service. Using OpenStack orchestration, or HEAT, we'll see a two-tier application deployed, including network and database components hosted on OpenStack and the scalable application itself hosted on OpenShift. For the webcast, I've used a JBoss sample application called TicketMonster. Here's an architectural diagram showing how it's deployed. All of the components shown within the diagram will be automatically created by HEAT according to a declarative manifest and can also be automatically removed by HEAT when no longer needed. On the right-hand side of the diagram, you can see the components hosted within OpenStack. HEAT uses the Nova and Neutron services to create a dedicated tenant network, deploy a new VM instance, install the PostgreSQL database onto the instance, and configure a floating IP address to make the database accessible from outside OpenStack. The left-hand side of the diagram shows the components hosted within OpenShift Enterprise. HEAT can integrate with OpenShift to create a scalable application using the JBoss EAP cartridge hosted within the PaaS. The PaaS is configured so that the application can access its database within OpenStack, although it could just as easily be a custom database as a service. Finally, the application is binary deployed into OpenShift. Now let's see the demo. I'm logged in here to a deployment of OpenStack Havana, and what you can see is I'm logged in as the demo user, and at the moment there are no VM instances deployed in OpenStack. What I'll do is just go down the left-hand side of the page to a couple of the sub-panes so that you can see what is configured. Firstly, I've pre-configured a operating system image which contains Fedora 19, just a simple base operating system. That will be used as the base image to deploy the database onto. And I've also got a very simple network setup involving a public network with access to the internet and then a private network behind a NAT gateway. When my TicketMonster application is built using HEAT, one of the things that HEAT will do is add in its own separate private network specifically for the database components. At the same time, I've also got an instance of OpenShift Enterprise running. This is OpenShift Enterprise 2.0. I'm also logged in as the demo user, and one of the things you can see here is that under my domain there are currently no applications deployed. So what I'm going to do is go back to OpenStack and deploy an application. So clicking Launch Stack, the first thing that OpenStack HEAT asks me for is the URL for the application manifest. I'm going to provide that. And then it asks for a name for the stack. So we'll just call it TicketMonster, which is the name of the application. And I need to input my password at this point. Having clicked Launched, then OpenStack will now go away and read the application manifest and start creating all of the different component parts in dependency order to build that application. One of the things that we can do is, as the build is going on, we can actually see what the progress of it is by exploring the stack itself. So if I click the stack at this point, then what we'll be able to see is all of the resources that are required to build the application. And in this particular case, there's quite a lot of them. So what you can see is there's a whole pile of networking components which are going to be built using OpenStack Neutron. That includes a brand new network for the database instance, and also a router to connect it to the internet, and a floating IP which will make it available to OpenShift. The actual specifics of how the database becomes available to OpenShift could be different depending on the way that your networking is configured in your OpenStack deployment. After all of the network components, then what I'll do is I'll just scroll down. What you can also see is that HEAT is going to deploy a database server, and it's also going to deploy an application into OpenShift, and that's using the OpenShift HEAT plugin to do that. So what we'll look at while we're waiting for this to build is, firstly, we'll go back to the network topology, and what you'll be able to see at this point is that HEAT has already added in a separate network which is dedicated for the TicketMonster stack. So this is the network here. We've got a NAT gateway which will connect that to the public internet, and you can see that Heat is already deploying a operating system instance on top of that network as well. What we'll do now is we'll take a look at the instance itself. And you can see here where previously there were no instances at all, it's now added a database instance for the Ticket Monster stack. It's got a floating IP address set up already, and the VM is up and running. What we can do is actually connect to the console, and we can see the installation in process. So in fact, as I've been speaking, the entire installation is completed here. What I can do is just scroll up a little bit, and what you can see is, all being well, you can see the work that was done at this point to install Postgres has already taken place. So what I can do is go back to the stacks view, go back to the stack in question, and at this point, if I click the topology view, you can see that all of the items bar one are now green to indicate that they've all been built. So the final item here, if I mouse over it, you can see is the Ticket Monster application within OpenShift itself. So OpenStack Heat has already built out all of the networking components. It's already built out the database instance and deployed Postgres on it. We're now just deploying the application, and this is a binary deployment, into OpenShift itself. So what I can do is if I go back to OpenShift and I refresh this page, what you can see is that the Ticket Monster application has been added here. If I click through to that, so what you can see is that this is a scalable application. So we've got the web load balancer component, and it's also deployed a gear for JBoss EAP with the application inside it. Now, all being well, that application is now fully deployed. I can go back to Heat, and if I click the overview and just refresh this page, you can see that the stack create is completed successfully, and Heat provides me with the URL for my application. So if I just click that, so there you go, the Ticket Monster application deployed using OpenStack Heat, comprising components on OpenShift Platform as a Service and OpenStack Infrastructure as a Service. All of the components of this demo are fully open source and are available online. The fully documented integration between OpenShift and OpenStack Heat is available at the GitHub link below. The GitHub repository also contains sample manifests, including the one used to build the application in this webcast. Thanks very much.